in this example, we have people planting flower gardens, which of course makes their neighbors happy. So we have an external benefit of $6 per garden. Okay, so demand for gardens represents the private benefit. So that means the value to the person who planted the garden, right? The consumer. The supply represents the private cost, the cost of production. And the external benefit represents the value that people other than the consumer get from the product. So I'm going to start here by calculating the market equilibrium. Of course, we'll do that by setting supply equal to demand. And we get 30 equals 1.5 Q. So Q is going to be equal to 20. And P would also be equal to 20. You'll notice that in these problems, price is much less important than the quantity, particularly at the socially optimal quantity, because there are multiple prices that can result in the socially optimal quantity. Okay, so let's just graph here. So we've got demand, and then we've got supply. Oops. Demand, that's our private marginal cost and private marginal benefit curve. And then we've got E price and quantity of 20. So there's our market equilibrium. And now we want to think about how that compares to the socially optimal outcome. So we're going to write down our marginal social benefit curve, which just takes into account the benefit to everyone in society, both our private benefit and our external benefit. And so what we have here, because the marginal external benefit is constant, we've simply shifted the demand curve up by $6. And that's our marginal social benefit curve. So, so here we have, that's what, 72. And our socially optimal outcome will be greater than our market equilibrium, right? The market fails to take into account the full benefit of the product, so it produces too little. Too few people will get vaccinated. There are too few beautiful gardens in the world, okay, because we don't take into account external benefit. So socially optimal outcome we would find by setting equal our marginal social benefit curve to our marginal cost curve. And if we solve for Q, we see that that's 24. And that's our socially optimal quantity. And now we want to be able to compare surplus at these two different outcomes. And in this problem, I've just asked for deadweight loss, so we can skip a few steps and just calculate the loss in surplus that comes from, the fact that we're not producing the socially optimal quantity. So we're producing less than the socially optimal quantity. And for our external benefit here, another way to sort of think about our total surplus is that, right, we're including our consumer surplus, our producer surplus, and our external benefit. So total surplus is going to be the area between our marginal social benefit curve and our marginal cost curve, and only out to the quantity that we're producing, right? So like here, we only go out to 20, and I can see that there is some potential to go further out to 24, right? So this is total surplus. The orange area is total surplus at the market equilibrium at Q equals 20. And I'm missing, what am I missing? I'm missing out on this area here. This triangle is my deadweight loss, which I would get if I produced a quantity of 24. Okay, so this is my dead weight loss triangle. So you want to figure out where the areas are on your graph that you need to calculate and then calculate them. That sounds simple, but sometimes people get confused. So first identify the area on the graph that you want to calculate, and then you can calculate it. Now, what we need to do is figure out what is the marginal external benefit at a quantity of 20, because that's the vertical distance here on our dead weight loss triangle. And that's easy because in this case, the marginal external benefit is constant. So at a quantity of 20, the marginal external benefit is 6, because the marginal external benefit, the difference between these lines, it is always 6. And then we can calculate our dead weight loss as 1/2 times our marginal external benefit times the difference in the quantity, and that's going to give me 16. So note that, like in this case, marginal external benefit is constant. So you could just plug this in from the problem. But that's not always true, and we'll do another example of that in a bit. Okay, so when we have a positive externality, the market underproduces, and we get less total surplus than potentially we can have at the socially optimal quantity. In this case, we're losing $16 in surplus from this externality, an uncorrected externality in this market. And now we want to think about some solutions. How could the government move to correct this problem? The first thing that we want to ask ourselves is, should the government intervene in this situation, right? And in terms of flower gardens, the government usually doesn't intervene too much, apart from the fact that we might have public parks, right? Where we have publicly accessible gardens that are funded by the government. And so that's certainly one option, right? The government can, in this situation, the government can provide the additional 4 units here in this case, right? The difference between the socially optimal quantity and the market equilibrium quantity. And usually that's free, that's provided free, but you don't want to provide an unlimited amount free, right? We don't want to have 72 gardens or 60 gardens, right? We want to have 24 gardens. That's the socially optimal quantity. And so it's important, right, to recognize that just because there's a positive externality doesn't necessarily mean that the goods should be provided for free by the government. It means that we're underproducing and we might want to encourage more production. And one way to do that, right, is to have this government provide some public parks, which is nice. Another way to do that is to subsidize either consumption or production, subsidize the product. And we see this in the case of vaccination, right? So the government subsidizes vaccination and preventative medical care, and to achieve the socially optimal quantity, right? Because again, we don't want to just offer it for free necessarily, because this is not socially optimal. What we want to do is just move from a quantity of 20 out to a quantity of 24. And so the subsidy that will get us there is equal to the marginal external benefit, because when I subsidize the product by $6, in this case, by the amount of the external benefit, basically I'm taking that external benefit of the product and I'm internalizing it to the decision that consumers and producers are making, right? The government is saying for every unit that we consume, there's an extra $6 in benefit. So we're going to take that $6 in benefit and give it to the consumer or the producer, and therefore internalize it to the market decision. And that would shift, say we gave it to the consumer, it would shift demand out by the amount of, it would shift demand up by the amount to the marginal social benefit curve. Okay. The third is really, if this is something that we need people to be purchasing, then we can require people to purchase it. And that is something that we also do for vaccination in terms of requiring vaccines in order to attend public school, for example, requirements to purchase car insurance, etc. So we'll talk a little bit more about insurance in the next unit when we talk about information, but these are basically the solutions to our positive externality problem.